Yes, don't hesitate to move closer, so I'm not, how to say, sorry? Yes, maybe. So let's talk about cross-team contribution and collaboration and tools and practices that help you to enhance that. And we'll talk about InnerSource, and some of you maybe already heard this term, but some of you not. And here is me, and I work as Evgeny said, I'm acting as engineering manager in retail company. And 4 or 5 years ago, my manager came to me and asked me, "Hey, Dima, have you heard something about InnerSource term?" And I answered no. And then my journey to the InnerSource world started. And we decided that it's our goal, since we are a multinational company and all business units, all countries doing almost the same process and trying to create almost the same systems. And we are trying to find a way how to develop the systems, make it common, but still have some differences at the country level. And InnerSource was a solution for us, and today I'm going to share with you my insights, my findings that I found during this journey. Yeah, let's start. And also I'm a board member of InnerSource Commons Foundation, is the community around the InnerSource, but I will tell you a little bit about it later. So imagine the situation when you have two teams. First need some feature from another, and second are not able to provide it to the first team. And they are trying to ask them, please send us contribution, code contribution, open the pull request rather than to send the feature request. And after some time, the first team returns to the second with the code. Second clicks on the big green button, merge pull request, and that's it. That was successful InnerSource collaboration. Of course, I'm joking. And the real end of this story will be finished like that. It's the set of questions from the first team. They are struggling about what the code, how to work with that system. The similar set of questions from another side, they also struggling with that. And in the end, we are finding that the both sides decided that InnerSource is not working. And everything what I will say here is it's not from the real life. But you're lucky and you are in the talk, and the talk will be about successful InnerSource collaboration, and I will share with you our findings, how we make it work. Okay, let's start from the term. The term says that InnerSource is applying open source way of development into the corporate borders, and to do almost the same practice and approach and tools and everything almost, but with the one difference that let's do it in the corporate world. And usually these situations appear when you have one requirement or one need, and this need leads to the change in the multiple teams. So for example, here is the example from our real company, real example. We decided that we should be good and improve at the pro workers. And to be able to handle that, we need to change the payment system, logistics system, communication, and other. And we came to this all of the set of the teams and asked them, please change something. Some of them actually changed, and some of them said, okay, let's return to us in 1 year. Maybe we will help you. And that leads us to the conclusion that we should prepare all of the teams to the InnerSource way of collaboration and make them able to receive the code and receive the pull requests. And the backward situation when you have one core team, and this core team needed by a set of the other teams, and they are frequently come to the team asking some features, and some of the features can be handled by their own, but the rest of them can be sent as a contribution way. And the these cases is the real cases when you can find the inner source approach and when you remove the bottleneck of one team or to deal with the priorities and the backlog with the multiple teams. And here you can apply the inner source approach. But in order to make this contribution successful, you should prepare these teams, prepare the products before, and I will share you my findings how to prepare you. I will focus more on the technical and operational side since we are on a back-end track, and we will talk about more code or some practices or tools around the code, but we will scan briefly around process and cultural stuff. If we are saying something about the practical and culture side, we should consider this as a checklist that you can check if your product or your team okay with that or your company. So imagine the situation when each team in the company have their own the Git system, have their own system for the backlog, and it's really hard to find what the priorities and what is actually how they are creating their products. And you should ensure that your company, your team have the open culture when you have accessible backlog, accessible code, you know how they work, you know how they are stylings and contribution conventions and so on. And ensure that they are prioritize their work according to the open source world if you want to be able to contribute it to them, and check the rest squares here in order to ensure that your practices and your culture is okay to work with that kind of collaboration. Let's stop here for now, but I think we can go back to the slide afterwards. Short off topic here, please consider conferences and conference talk not as a source, not as the main source of information. Let's consider talks as invitation to the discussion afterwards. So I'm more than open. I will share the contacts. I will be here somewhere in the corridor during the whole 2 days. Maybe afterwards we also can speak about these factors and other factors. You'll come to me and ask, says that InnerSource is not working, and we can work with that. Okay. Let's go to the main content. Is the technical and operational part of the InnerSource. I will share you the story from the latest project that I worked for, and we prepared to work in the multinational mode when different business units should be able to contribute there. And yeah, let's go. Let's start from the architectural part. Imagine your goal is to build the best system in the world. It means that multiple countries and multiple business units should work with that. They have their own priorities and their own needs, but some core of the system should be common. So you decided that it's not a choice to create 3 or more separate systems, but yeah, you should measure and count the differences in each country. And from the scratch, we decided that monolith approach it's not okay for us, since it will be hard to manage all of the stuff. And we decided to go to the modular system when you have some microservices common, some microservices custom for specific need for specific business unit, and those allowed us to at least to be able to create those systems. Then our system was split into models, but we still had business process spread to multiple microservices, and we still had transactions, and in our world that was distributed transactions, And we choose the orchestrator, and usage of orchestrator was really helpful to handle this kind of business process that was light on multiple microservices. So we choose Camunda, but you are able to choose any of available BPMN engines on the market. And that also helpful was for us because if we need to change the business process, we not changed the code. We changed the BPMN script, and that was easy. We did it through the UI, and UI also convenient for monitoring what is happening there. So that approach helped us to build those systems. Then the goal was to integrate the system with the outer world. So we adopted adapter approach when we had some adapters in common, when we had adapters for specific external system, and that allowed us to keep free from the specific environment, the core part of the system, and then to make the specification, make the concrete APIs and so on the adapter level, and that allowed us to integrate the system to multiple environments. Then we have the same situation when the requirements was different when we're talking about front ends. Some of the business unit wanted their own design system. Some of them wanted mobile application. Some of them still used the web application. And we did the same on the web application layer when we had micro front ends injected into the web platform, and then it's allowed us to make some part as a core, as a common, and then to create some parts of the system custom on the specific need. And in the situation when we had multiple front ends on one side, multiple backends on other side, we decided that we need to have something between them. We chose the backend for front-end approach. We already had platform for that, and on the lightweight JavaScript, we created the backend needed for specific front-end. But the GraphQL also can work here. And what I want to say in general, that those architecture was as an enabler to that kind of work when you have some part is common, some part is custom for specific need for specific user, and architecture enabled us to make this collaboration happen, to make the system at least work and at least possible, because previously we had a lot of experience of and failures when we decided that, okay, let's create the common system, and then spending the time and years in nothing. But here is the successful example. Okay, let's go to the part that I called everything as code. Since we have modular architecture, we need to express this architecture, and the popular way of express is C4 model, C4 notation. But we went further and decided that let's store the architecture picture in the code in the plan.uml format, and then render it when you need to show it and when you need to place it somewhere in the documentation. And it's great to have the opportunity to change the picture without any knowledge how to work with specific systems. You don't need to go to Draw.io or some other platforms. You're just changing the code, and it's rendered it automatically, and it's really easy, and that helps us to keep the picture updated. The same for documentation. So we decided, since we have specific need that we should onboard the external developers through the process how we develop, how the system is actually working, we need to have, it's must to have a good level of documentation, but also it's must to have the updated documentation. And if the documentation lies somewhere too far from the system, it's going to be outdated. And we decided that it's not a choice for us. We placed the documentation in a doc format, right in the code, and then used the built-in functionality of GitHub and render it on the fly. And that approach helped us to easily keep the documentation fresh and detailed. The same for the activity diagrams. We used plant.yml format in order to store everything as code, and also store as code the pictures of the flows, and then standard functionality of the Git, render it on the documentation, and that was perfectly suits our needs. And what else? As a subsequent work, we not deal with that, since we have everything as code, and here we are able to make the test around that. We still not handle that, but it's our future, and our goal is to create the test that that levels are okay, that architecture is okay, that we are not breaking any rules, and since we have everything as code, we can create a test around that. Then, since our system integrated with other through the API, it's a must to have the contract. We decided that let's create the contract and store it somewhere in the Open API standard. But what we decided also that we should live in the API first approach when you firstly creating the API, and then in parallel you're creating backend code, front-end code, test around that. You're able to generate some code from the contract, and that highly increased the speed of development, since we are not waiting for somebody that is going to implement something, and also increase the quality of the code, since we 100% sure that our contract and our code is working together, and it's the one single entity. And the same approach, everything is code in the infrastructure level. So we decided that our code will be common. Our Docker images that was generated from the code also common, but deployments are separately and isolated. And in order to replicate the deployment, we are expressed in the code the infrastructure needed for the solution, and then replicated as many times as we need, and that allowed us to multiply deployment that we have. So that's all for the everything as code approach that we used in our project. Let's talk about automation. I'm sure that all of you, I hope that all of you choose some flow in Git. We choose GitHub flow, since it's a pretty default flow in the open source world. We decided that some other flows like Git flow or others quite hard to maintain, especially if you are working with external developers that's going to send you some contributions. And that perfectly fitted to our need. We have a main branch, we have feature branch for specific need, and this feature branch is short-living and then merging to the main and feature on production. So we decided that it's a pretty simple flow, help us to boost the speed and still have a good level of quality. And in order to make this feature branch short-living, we applied feature flags approach. When you're able to merge the feature the time when you're not ready to have it on production, and then enable it when you need that. So this will allow us to not have problems on the merge stage. You're not waiting for somebody. We are not trying to solve the problems of merging, since your feature branch is too old, and this approach helped us to remove that. Each branch had a separate deployment. We are able to click manually any kind of any state of the system, any change, and our environment make the available run the microservices, databases needed for that, different queues, and do it separately from the production layer. And yeah, our contributors are really happy that they are able to test what they are trying to merge to the master. Talking about code reviews, the number of them will be increased since we are dealing with the contribution from other teams. And here is the, I will say, anti-pattern, since 4 developers spent their time in order to check what is going on there. It's tricky part. That's from one side you need to ensure that the quality is still good, and on another side you are spending some time of developers. Maybe you can reduce that. But here the point that we should increase the quality and culture of code reviews and teach people how to make it properly, and still maybe reduce the number of required code reviewers and so on. But in order to speed up the process, we can apply multiple automatical checks. Since we are on automation part, here we can apply the different set of linters, checkers, and tests. And imagine the situation when you are opening the pull request, waiting several days, and receiving the comments that please check or remove the space here, or check replace the tabs with the spaces, and so on. And it's hard to understand your feelings, because you waited for some time and received this, and maybe in this situation, if linter will say almost instantly that please check that, and our standard is write the code like that, it will be much easier and much faster. The level of automation here on one side increases the speed, on another side increases the quality of your system. So that's it for the automation part, but we still not talked about convention and agreements that you should apply and animate and express to all contributors, and conventions can bring to you the stability of the system and the stability of the code. Then you should decide what tool are you using for backlog management. Is it enough to use issues in the Git, or you prefer to use standard corporate work tools like I don't know, Jira or others? And the point here is to check is those tools are okay to external developers that is going to send to you the contribution to the feature, to the backlog, and we should check also. Developer portals or popular nowadays developer platforms can extremely boost the productivity of engineering of the InnerSource collaboration, since platforms provides the standard way how to deploy the feature, how to at least how to find the solution, and you will know that there is specific product already solving your need, and you don't need to create your own solution, and you can scan through the developer portal, and that's extremely helpful in order to boost that kind of collaboration. The testing strategy and testing parameter, we haven't spoken about that, but you still should be 100% sure that your system will still good in terms of quality, and you should think how you are testing your product. On one side, you can ask contributors to test your product. On another side, you can test the incoming contributions, and each of the options have their own pros and cons. And the point here is that we should prepare the strategy of testing that's suitable for the process. We haven't spoke about management of dependency, how we deal with the external dependencies, do we provide internal dependencies, do we provide any SDKs, and so on. Maybe the point that we should also talk. And observability. So is your applications providing the needed set of metrics? Do they producing the logs in the specific standard needed for specific environment? And all of the stuff around that's still a good topic to discuss if you want to prepare technically the system to the successful InnerSource collaboration. So here is the checklist that we should pass in order to check is your system good for this kind of collaboration, or you can look for some other solution to boost this way of collaboration. Okay, what I want to say with all of the slides. The time when it was you as a developer, as a single developer, was able to sit in some room, write the code for a month, and then provide the solution that's used by anyone already gone. It's really a frequent situation when we have the products developed by a single product. Almost any solutions that we use every day is the product of multiple teams split into multiple countries speaking in the different languages, and we cannot invent the wheel here, and we can reuse the practices that already working and already proven in the open source world and bring those to the corporate world and prepare our teams and prepare ourselves to the future and to the modern requirements, since also the feature request also high now, and the audience and customers not able to wait for the month when you will provide the feature for them, and you should prepare your processes and tools and culture for that kind of development. We spoke about cultural stuff briefly and technical in details, and I'm sure that you have your own experience and your own tools or things that you used in your practice. And I think after the talk, please raise the hand and share your findings. That will be also helpful for that. Or share your failures also, because I think almost all of you faced with some situation when the collaboration was unsuccessful. Okay, so that was the cultural stuff that we scanned briefly, and we should check if we okay or not in order to, if we are speaking about practices and culture. Here is the technical part that we spoke more details, but still scanned briefly through the rest of them. And I want to finish my talk with the Google findings. They started a 2-year research project some years ago in order to find the best set of knowledge or best set of personal abilities or skill set. They talked with high-performing teams and asking them what skills or what individual traits would be the key ingredient of the high performance. And what they found instead is the finding that who is on a team matters less than how team interacts, how the team work together, how they view their contributions. And in other words, so let's focus less on the individuals here. Let's focus more on the structuring of the work, on the processes and practices and engineering culture overall. What can be helpful in that journey? So is the materials of the InnerSource Commons community that we provide. So we applied pattern approach here. We created the set of activities or practices that it's not visible here, but it's visible in the link. So what is the standard? So there is a set of companies that tried some approach in their company, and they expressed the results and failures and the successes, what they achieved during this practice, during this experiment. Also join the community is the set of practitioners around the globe from multiple countries, multiple companies. Our goal is to make the InnerSource the standard way of development in the future. And I think you may notice that I'm saying InnerSource, but you have something similar in your company and you're not calling like that. You're completely true, but if we are naming it like that, so we are able to collaborate around this mechanics, around this way of development. And afterwards, we created the set of events, we created the learning path, and you are able to scan through these documents and reuse it in your company. let's create the contributions and collaboration where it's easy to click on the green big button merge request, and let's enhance our cross-team contribution using the InnerSource tools and practices. Thank you. Now is the time of the questions.
Yep.
Thank you for the great talk. I have a question about like interaction between non-tech and tech teams. Did you have any intersections? For example, did you have to educate someone who usually don't write code, how to write code, to do everything as code, like to paint diagrams as code and such things?
Mm-hmm. So first of all, as I said previously, it's important to know the basics of how open source works, to apply it to the inner source. And it's the requirement to teach all of your participants, technical and non-technical, to provide them information how you can work with other team, what you need to learn about it, and what roles and responsibilities of each participant of the process. Secondly, of course, that was a great situation when we have the people who are not writing the code, but they was still too technical to be able to change the architecture, to change the documentation and so on, and some level of knowledge that was a requirement for them. But it's not rocket science. We explained them in 30 minutes how to use Git using the UI, and they was able to continue to develop everything. Am I answered your question? There are a few more. Thank you for your questions. It's a breadth for speakers and points where we can learn from each other. Thank you.
Yeah, thank you. So as an architect myself, one of the hardest things about being an architect is making a decision now that impacts the company in 2 to 3 years. And when you make those decisions, they're very heavy, as one small mistake can cause months or years of tech debt to accrue. As you've worked through the different companies and different people doing that, how do they typically work with the architects and senior engineers to ensure that large amount of tech debt isn't accrued while everyone can still put new items and features into the system?
So, am I understood your question right? That's so you have the system was built in the inner source mode. Who will decide is the feature good or not in the architectural layer and other stuff?
Yeah. So if, for example, if I'm wanting to add feature Y,
yeah,
but that's going to conflict with features A and B that we built our core model off of.
Got your question.
If I want to do that, how does that work in the inner source model?
So the true inner source model as an open source inside the corporate world, and there you have a distributed way of how to say determining is this feature good in terms of the long-term planning or not. But in my experience, that was not worked. And in my experience, we had the maintainers who had architectures and so on, and they decided that, okay, this feature looks like not so good, and it's not good approach to implement this feature like that. And they advised, okay, let's go to another part of the system and create the code there. And that work of maintainer, that's the role of maintainer to explain the external contributors the proper way how to handle this feature, how to create the code around that. That allows us to have no problems in the future, but there also had some problems in order to. So you came to me with the code, and I'm saying that, oh, your code is not good enough, and please do it in another way. That was tricky part, but yeah, the the point here is to, if you want to send the contribution, it's not a good choice to send the contribution and then to talk with the team. It's a good choice to talk to the team before, say, so here am I want to change something in your system, and then the team advise you how to make it in the best way. That's it.
Awesome, thank you.
Thank you.
Thank you, Dima. Awesome talk. I don't have like InnerSource in the company myself, but I'm very interested in part of processes that you didn't cover. So it's like a small question about it. So how you like support documentation and standards and like so that's practice like that you should use a tabs or whatever, like with automations of the code, because like you need the resources for that. So is a team or contribution constantly to support for external maintainers or something different? I don't know. Can you share with me?
Okay, so each team who supports work in the InnerSource mode, creating the special documents called contributing guide. And in this document, you can explain who are responsible for what. For example, you can say, if you're changing something, it's also your responsibility to update the documentation here, and here is the instructions to update the architecture layer, and here is how you can do that. And tests we are doing by ourselves. For example, we don't believe that they can create enough quality of tests. Or we can also say that please create the unit tests and the integration we will do on our side. And here, this document will explain to externals and make the expectations of externals right what you have in your project. And for your team, it's also important that the contributions coming to you is okay in order they are, how to say, following the rules that you have in your product. Thank you.
Awesome talk, thank you a lot. I have a question related to the part where you said that everything has code. I really like it. Versioning is awesome. Whenever you want to go back to history, you have this option using it. But most of the issue that I'm dealing with is the outdated documentation. Even if there is a guideline how to update documentation, is still a pain for most of the team to update this documentation. How you are dealing with this issue?
So it's again about agreements that you have in your team, in the contribution convention for the other teams. Since the level of activities, or since it's really easy to handle it by your own, and you don't need some specific need or some specific notation, and you're doing by example here that all tools accessible to you throughout the browser, and it's a requirement in order to pass the quality gate, in order to merge your change. So you will have updated documentation, and it will be not a pain for you. But still, of course, you should spend some time on documentation, since we are agreeing that it's a must for us, since we are working with many teams, and we are not able to work without documentation.
Do you have guidelines where, I don't know, shared guidelines with the team that this is how?
Yeah, sure. There is the guideline how to contribute to our product, and the part of this contribution guide also will focus more, okay, you need to update documentation. Here is how. Okay, you need to, if you need to update the architecture, here, please go there, learn how PlantUML works and change here. And also, if you have any questions, we are able to consult you. So we, as a maintainer, it's our role to mentor you in order to successfully update the code in our system. And on the first occurrence, maybe you will spend the time on that, but second time or next times, you already know how you work, how our documentation works, and it will be easy to you. Thank you. There is 2 more questions, and then going to the rest.
Hello, thank you for your speech. Yeah, it's really cool, InnerSource, but can be back to real life. What happens and what you do if you have some incidents in these tools? Because you have also maintainers, but I think they have some job, yeah. And how you decide who can fix it, because you have a lot of commits and tests did by users.
Okay, that's a really good question, and I can rephrase this question. Some other guys will come to my system, change the code that I don't need, and this code will break whole system, and how I can deal with that. So as a maintainer, you are taking responsibilities of support of any code that you received from external world. So you will fix those code since you applied it. But you can apply some approach that can help you to handle that. For example, 30 days warranty, saying that if you are sending the code, of course we will, so we have some SRE or some operations on top of measuring is your system good or not. But if we need to change the code, then you are saying that you have 30 days when you are going to change it. But afterwards, no, the maintainers.
Yeah, you a little bit simplify my question, because people who is maintainer, they need to spend time to find this piece of code that now is broken. And you ask only maintainers to go to the incident, or you ask everyone who commit, I think, previous 2 weeks?
Originally, it's only maintainers, and they code reviewed all incoming code, and then it's they are familiar with that. Of course, not in the details, but then it's the goal for maintainers to know the code base that they support.
Okay, thank you so much.
Thank you.
Yeah, I really like this idea as a developer, but as a CEO, I just want to know what is the overhead of this approach. In other words, how much shall I pay extra to the developers in order for them, in order to make them happy and in order to support this workflow?
It's a good question, and usually it's not too hard to sell these ideas to top managers, since they can measure the potential pluses and benefits that they can achieve. That's you're reducing the bottlenecks, reducing the code that you're creating multiple times in somewhere, and also sharing the knowledge across the system, and so on and so on. But as a disadvantage, of course, you should spend some time in order to prepare the projects, to prepare the documentation, to explain how to work with that, and so on, and how much. But the good point here is any coin that you are spending on that is the coin that goes to the engineering maturity, to the stability. You're creating the tests, you're creating the documentation, and so on. And any potential sum that you can announce that it will cost you some hundreds or thousands of dollars, so you're spending in your engineering stability and so on, that help you to to avoid some potential failures and so on. So that was the answer, and it highly depends on your system, on your situation. For example, your products already can have some of the items that I mentioned, and it will be easy to you. Or, for example, you can live in the cloud source, use SVN, and not talk with anyone. Of course, it will be priceful for you.
Okay, we are running out of the limits. So, Dmitrii, again, thank you very much for your amazing talk. And that's it.
Thank you.